Random variables x and y have joint distribution given below. Let A be the value that minimizes the variance of x. Calculate the variance of y. So expected value of x equals summation of x against marginal probability function of x. So that's 0 fx0 plus 1 fx1 plus 2 fx2. We are trying to find the variance of x first because that will help us determine what this A is. So for variance of x, you need first E of x. So fx, so now I don't care what fx0 is right now because that's just timed with 0. So basically I just have 1 fx1. fx1 will be basically summation of all these columns where all of this column where x is equal to 1. So x is equal to 1, then y is 0, or y is 1, or y is 2. So a plus b plus a. And then 2 times fx2. fx2 is the summation of this column, 2 over 15 plus a plus 1 over 15. And that simplifies to 4a plus b plus 0.4. Now, the sum of marginal probabilities over all the values is 1, because marginal probability function also has all the properties of probability function, that all the values have to sum to 1 in case of discrete variable. So fx, summation of fxx equals 1, but summation of fxx equals fx0 plus fx1 plus fx2. And now fx0 is the summation of this column. So 1 over 15 plus a plus 2 over 15. Similarly, fx1 was this, a plus b plus a, and fx2 was 2 over 15 plus a plus 1 over 15. All this simplifies to 4a plus b plus 0.4, and as we said, this was all the summation of fxx that has to be equal to 1. So from here we get 4a plus b equals 0.6, and now we can substitute this 4a plus b in this equation. So we get 0.6 for Ex equals 0.6 plus 0.4 equals 1. And now usually we get variance of x by E of x squared minus Ex whole square. But remember that the basic formula for variance, when we learned variance for the first time, was this one. It's the expected value of x minus the mean whole square. And this one is more convenient here because we already have the mean, which is 1. And since there are letters running around, so this is more convenient than the other formula, because I mean, you will have a lot of variables. You will have some variables to work with. I mean, you can still do it the other way, but I'm just doing it this way, but it's slightly shorter. So summation of x minus Ex whole square. So expected value of x minus Ex whole square is the summation of x minus Ex whole square against the marginal probability of x. So that's equal to x minus 1 whole square against fxx, because E of x is 1. So x minus 1 whole square, so you again substitute the best possible values of x, which are 0, 1, and 2. So 0 minus 1 whole square, fx0 was this one. Okay, 0 minus 1 whole square fx0 plus 1 minus 1 whole square fx1 plus 2 minus 1 whole square fx2. And fx0 was a plus 0.2. I've just simplified this. This is fx0. So this simplifies to a plus 0.2. 1 over 15 plus 2 over 15 is 0.2. And then this simplifies to 2a plus b. That was fx1. So 1 times, but I don't care what fx1 is because that's being multiplied with 0. And then when x is 2, it's 2 minus 1 whole square fx2, and fx2 was also a plus 0.2. So this one simplifies to 2a plus 0.4, and that is variance of x. Now we are told that variance of x is minimum at a. A is that value that minimizes the variance of x. A is the value that minimizes the variance of x. And variance of x is 2a plus 0.4. Let's just write it here. So it's all variance of x on the left side. So A is a probability. Remember, A is one of the entries in this. So A is a probability, and a probability is always greater than or equal to 0. And so the minimum value of variance will happen at the minimum possible value of A, which is 0. Right? Since A has to be greater than or equal to 0. So this expression 2A variance equals 2A plus 0.4 tells us that the variance will be minimum when A is minimum, and the minimum value of A is 0. So that means that A is 0. So variance of x will then be 2a plus 4, 2 times 0 plus 2a plus 0.4. So 2 times 0 plus 0.4 equals 0.4. And now the question was to find variance of y. We have found variance of x to be 0.4. If you look at this table, it's completely symmetric in x and y. So by symmetry, we mean that if you interchange x and y, the values of probabilities remain the same. So for example, y as a probability at 0, 1 is a, and at 1, 0 is also a. Similarly, 0, 2 equals 2 over 15, and probability at 2, no, okay, I was reading it the other way. So when x is 0 and y is 1, so the probability at 0, 1 is a, and then probability at x equals 1, y equals 0 is also a. So 0, 1 probability is the same as 1, 0 probability. And similarly, you can check every ordered pair. If you reverse the ordered pair, the probability value is exactly the same. So that means that whatever is true of x is true of y, and we found variance of x to be 0.4. So variance of y also will be 0.4, and choice A was 2 over 5, which is 0.4. So the correct answer is A.